Okay, well we'll get started then. And today we are continuing on in this land of the nature of data and then descriptive statistics. And so today our topic is the nature of data. All right. And when we're talking about data, we talk about information that we have collected and organized. Okay? So data And one way to organize our data is by using a data table. Okay, so we often organize in a data table. And when we create a data table, there's different ways to do it. And I recommend a particular way in which every row in our data table represents an observation. Okay? So this is kind of my recommended is to have every row is an observation. Okay? So every observation gets a row, every row is an observation. And then every column in our table is a variable or a piece of information that we have collected about each observation. And if you set up your table this way, where every row is an observation and every column is a variable, the textbook calls this the stacked format. But and they mention the unstacked form, but we won't dwell too much time on the unstacked form. All right, and so we might obtain a sample of data, and we might want to collect some pieces of information about this sample of data, and we would organize it in a table. Okay, so let's say we have a sample of data. Let's say our sample is, we randomly select let's say 40 students who are enrolled in Stats 10 at UCLA. Okay, so this is our sample. Our sample is 40 students selected randomly who are enrolled in Stats 10 at UCLA. What would the corresponding population be? If this is our sample, what's our population? Okay, so the population would be all Stats 10 students at UCLA. Okay, if our sample is, we've drawn 40 people from the population, our population is then all Stats 10 students at UCLA, right? You know, we have plenty of seats in the wings, so if you don't have a seat in the regular classroom, you don't have to sit all the way back there. It's all okay. And all right, so let's say we've gathered some information, and we're going to organize this into a table. All right, and so we might talk about, you know, what's our student's name? Maybe we'll take the student's age measured in years, and we will ask for the student's height. Oops, that's not how we spell height. And measured in inches. And then maybe we'll ask for the student's sex and ask for the student's hair color. All right, and we'll just make up some information. We'll pretend that we've selected a student. This student's name is, we'll say Alice. Alice is 22. She is 64 inches tall, female, and has black hair. We'll have a student, Bill. Bill is 19, 69 inches tall, is male, has blonde hair. Okay, and we've collected this information for all of our students. So how many rows will I end up having? I will have a total of 40 rows of data. Okay, one row for every student. Okay, so this number 40, we're going to say n is equal to 40. N is our sample size, and it's also going to be the number of rows in our data table. Okay, so n, our sample size, we're going to have 40 rows of data. Obviously, I don't want to write out 40 rows. Okay, so we're just going to pretend that we've collected this information for everybody. All right. Let me just copy this onto the next slide. You obviously don't have to copy it to the next slide because you still have space in your notebooks. When we're talking about the variables that we can collect, we broadly say there are two types of variables that we can collect. Okay, so broadly speaking, there are two types of variables that we can collect. We have categorical variables. Okay. Categorical variables, these tell us what type or what kind can be used to make classifications or can be used to categorize our observations, or used to make, used to classify. Those would be categorical variables. We're not arranging, if we don't have categorical variables, then the other type of variable that we have would be numeric variables. Numeric variables tell us how much or how many, a kind of quantity. So sometimes these are called quantitative variables. Or, you know, whatever they're talking about, they say quantitative this and that. They're basically saying numbers are involved. Okay? So numeric variables tell us how much or how many. Okay, and so categorical variables can be used to classify. Numeric variables can be used to kind of sort or arrange from least to greatest, things like that. And it would make sense to, well, you know, loosely speaking, talk about different quantities, and some observations will have larger or smaller quantities than other observations. Okay. All right. So if we go through kind of this mini table that where we've collected data, let's just talk about each of these variables. Is age categorical or numeric? Okay, you'd say numeric. And height is also numeric. Sex, categorical. And hair color, we'll also say categorical. Okay. What about name? Name would be, yeah, we'll say it's categorical. And some people might say this is an identifier. Okay. Let's say I throw in another variable here. Okay. Let's say we have zip code. All right. Alice lives 90049. Bill lives 91. I don't know. Just making up some numbers here. All right. Zip code, is this numeric? Is this categorical? What is it? It's categorical, okay? Even though it's represented with a number, that number doesn't tell us how much or how many. It's just a number. So it's categorical because, you know, at some point it would make sense. We can say, you know, we want to arrange people from oldest to youngest. Okay, we can arrange people by their age. That makes sense. Okay, and it would make sense for Alice to say, I am 3 years older than Bill, or I am 5 inches shorter than Bill. Okay, if they're comparing their heights or ages. But when it comes to the zip code, it doesn't make sense for Alice or for Bill to say, you know, I have almost 1,000 more zip code than you, and that makes me awesome. Because the zip code has no inherent value, right? If this was, you know, amount of money in your bank, well then Bill could say I have almost $1,000 more dollars than Alice, and we'd say, wow, you guys both have $90,000. That's impressive. But as far as, you know, zip codes go, that there's no quantity. It doesn't tell us how much or how many, so it's a categorical variable. It's used to classify people based on their geographic region, and we just happen to label these things with numbers. So just because something has a number doesn't mean that it's actually numeric. Okay. So we've got numeric variables like age, but in fact we can often turn these numeric variables into categorical variables. So numeric variables can sometimes be made into categorical variables. And so, you know, generally, if you ask someone, how old are you? They would respond with a number, okay? If they don't give you any attitude, they would say, I am, you know, this many years old, okay? If you ask someone, how old are you? They would generally respond with a number. That's kind of the expectation. But if you were to respond to a marketing survey, they probably won't ask for your age outright. They might say age, but then really what they list are age groups. Okay, so age, which is a numeric variable, can be made into a category by saying age groups, and they would list off things like which of these age groups are you in? Are you in the 18 to 24, the 25 to 34, 35 to, I don't know, I'm just making up numbers, 49, 50 to 64, and 65 plus. These are often kind of the different age groups that we see on a marketing survey, and you would just put the little check mark in there and say, you know, this is my age. So this is now age, which we traditionally think of as numeric. This is now a categorical variable. On the other hand, it doesn't really quite make sense to go from a categorical variable to numeric variable. In some cases, it could make sense, and we would call those ordinal variables, but we're not going to get into that. But you know, let's say we were talking about, you know, what color is your car, okay? And some people have a silver car, some people have white cars, some people have black cars, some people have red cars or blue cars, or you know, you can get all sorts of different colored cars. And let's say somebody says, well, I don't want to hear the color of the car. I just want numbers, okay? How are you going to assign numbers to each color? You can say, well, we're going to say red is the number 1, and white is the number 2, and black is the number 3, and silver is the number 4. You could do that, but then someone else can say, no, you did it all wrong. White should be 1, and silver should be 50, and black should be 100, and red should be 200. You know, you can have different ways of assigning numbers, and none of them make any more sense than the other, okay? And so to go from a categorical to a numeric variable, that doesn't quite make sense, okay? But numeric variable to categorical, that's often easy to do, okay? Speaking of categorical variables, okay, it's often a complicated task to decide how many categories there should be, okay? So if we're talking about hair color, we can say, oh, people can have black hair, brown hair, blonde hair, and red hair, and something like that, okay? So, you know, I listed off 4 colors there, broadly speaking. But if you go to Target and you go to the hair coloring section, do they have just 4 colors of hair? No, they've got maybe like 30 different shades, okay? Maybe if you look at like coloring for beards, there's only a few colors, but in general, there's lots of colors, and depending on which company you look at, you know, they might have, you know, 20 shades of hair color, and another place might have 15 shades, or, you know, if we're talking about makeup and foundation color, which is supposed to match your skin tone, you know, they have all sorts, you know, different companies have different, I don't know, okay? And in fact, it gets so complicated that oftentimes the companies resort to having a number assigned with each shade, but then so then when my wife sends me to the store, she can say, I want this number shade, and that makes my life easy. But if they don't have it, if they don't have that exact number, I'm in big trouble because I have no idea what the right shade to pick out is, because there's so many colors, right? So how many colors or how many categories to have for something like hair color is a hard thing to do, okay? Even something like sex, how many categories are there? This is a more complicated issue than what used to be thought. And so, whatever we're talking about, if we're dealing with a categorical variable, it's generally a good idea to include a none of the above or other category, because you might think there are certain categories, but especially if you're dealing with people, you'll have people that might not fit into any of the categories that you have listed. Okay, so the number of categories for a certain variable. Can be a difficult thing to decide. Okay, so it is good practice to have a none of the above or other option. Okay. All right, and so that, here we have numeric and categorical variables. Again, the foundational difference is that categorical variables tell us what type or what kind used to classify things. Numeric variables tell us how much or how many. Okay, and you've got to be able to tell the difference between what's a numeric variable and what's a categorical variable. If you can't tell the difference, then you're going to have problems in the class, because later on, as we go through, the way we approach an analysis will change dramatically based on whether we have a numeric or a categorical variable. So it's important that we can distinguish between the two. Okay. And there's a certain irony in that I said you should always have a other option for the categories, and I said, well, there's only two types of variables, but yeah. Okay. I also want to talk about gathering data and how we might collect data. Okay, so gathering data and sources of data. Okay, and so one source of data we might call anecdotal evidence. Okay, so anecdotal evidence, these would be things along the lines of, my aunt did this thing, and then this happened. Okay, my aunt, she had, I don't know, arthritis, and then she did this one thing, and then something happened. Okay, that's a form of anecdotal evidence. Other forms of anecdotal evidence would be customer testimonials, or customer reviews. These are anecdotal evidence. And from a statistical standpoint, there is not much that we can do with anecdotal evidence. Okay. And don't take that statement to mean that anecdotal evidence is useless or anything like that, okay? Because customer testimonials and customer reviews, it's important and it is useful. It's just from a statistical standpoint, there's not much we can do. The entire business of Yelp is based on customer reviews, right? And Amazon, you know, before I buy anything, I always go to Amazon and I check for reviews to see what people have to say. This is all anecdotal evidence. I read through and all of these are kind of in the form of, you know, I bought this thing and this is what happened. And, you know, just from a statistical standpoint, it doesn't mean that because it happened to one person, it's going to definitely happen to other people, okay? And that's kind of the trouble with anecdotal evidence. But it's still useful. The other hand is, you know, when you look at you try to average these star ratings on Amazon, and, you know, one product has a 4.6 and another product has a 4.2, from a statistical perspective, that 4.6 isn't necessarily a 4.6 and that 4.2 isn't necessarily a 4.2. Same goes for Yelp reviews and things like that, because there's not, it's hard to do anything with this stuff, okay? Similarly, you know, well, in California we just legalized marijuana, but, you know, medical marijuana has been legalized and is legal in many states. And a lot of people will say, you know, I was suffering this thing, and the usage of medical marijuana has helped alleviate these things. That still falls under anecdotal evidence, and it's difficult to do anything from a statistical standpoint. There isn't there isn't very much actual, you know, scientifically researched stuff on the effects of marijuana. There's some, but there's probably not as much as there could be or should be, probably largely in part because of the federal regulations on the usage of marijuana, and you would need to get, you know, special licenses to do any kind of medical research using marijuana. You can't, it's not like doing research with Tylenol, okay? And because of that, there's just not as much research as we might want, and therefore a lot of things are anecdotal, and so it's difficult at this point in time to do anything from a statistical standpoint. Okay. So let me just talk about some methods that allow us to use the data and analyze it statistically. And so for that we have observational studies. Okay. And the big picture with an observational study is that we are just observing our participants, okay? We observe our participants. And we try not to interfere. So we try not to interfere with the participants, other than taking measurements? Okay. When we do an observational study, ideally, our subjects or our participants are a representative sample of the population. Okay, and whenever I write the word ideally, it means ideally this is what would happen. In real life, this is rarely the case. Okay, so ideally means, you know, in our dream scenarios, this is what it would look like, but in real life, it's not really so much. Okay, so ideally our subjects are a representative sample of this population, and also ideally, but not really in real life, we gather all pieces of relevant information. Okay, we gather all variables that could be related to the outcome of interest. Okay, so when I say the outcome of interest, you have to think back to the research question that we have posed, right? So we said in science is made progress. In science, we make progress by answering research questions, and so the research question could be, you know, is this drug effective? Or, you know, what things might reduce rates of illness? Or, you know, what factors are associated with, you know, I don't know, high school graduation rates and things like that. Okay, so we would gather all the variables that could be related to this outcome of interest, right? And again, this is ideally. In real life, we can probably only gather several variables of interest, because every time we're trying to gather information, that takes energy, time, and resources to do so. But ideally, we can gather all of this, okay? And then at the end of our study, we might find, through our statistical analysis, we might find associations between certain variables and the outcome, okay? At the end of our study, we may find there are associations between the outcome and some of the variables. Okay, so for example, we may say that we observed that people with diets high in vitamin B developed, I don't know, cold sores at a lower rate. Lower rate than those people who did not have diets high in vitamin B. Okay, so we might find this kind of association through our statistical analysis. However, we cannot say that the association is a cause and effect relationship. Okay, we cannot make a cause and effect relationship. We cannot say that diets high in vitamin B then cause lower rates of cold sore development. cause and effect conclusions. Okay, so I'll say do not say. You know, diets high in vitamin B reduce the development of cold sores. Okay, because this implies that having a diet high in vitamin B is going to reduce that it causes the other thing. Because the truth is that it could be the vitamin B. The vitamin B could be what's causing lower rates of cold sores, okay? But it's also possible that, you know, we didn't gather this information, but maybe diets high in vitamin B are also high in vitamin A, okay? And maybe it's vitamin A that is responsible for reducing the cold sores, okay? And it's just that when we looked at people who had diets high in vitamin B, maybe those diets also tend to also be high in vitamin A. And maybe that's what's reducing the cold sores. We don't know, okay? There could be, you know, what we call lurking variables. So I don't know where I'll fit this. Just squeeze this in here. There could be lurking variables. If we looked at households across the United States and we looked at something like how many iPads does this household own, and you know, let's say how many iPads and gaming consoles and I don't know, smartphones exist in this household versus you know, how well are the children performing in school, okay? And it might not be a super strong relationship, but there will be some kind of association where households that have lots of iPads, gaming consoles, and electronic devices and such will tend to have students that perform a little bit better in school than households that have very few of these devices, okay? And does that mean if we want to increase academic performance across the nation, the answer is to buy millions of iPads, give them to every household, and see what happens? No, that obviously would not work. So what's going on there? So, you know, and the answer is it's complicated, okay? It could be a, you know, socioeconomic status thing, and maybe in large part, well, it's kind of accepted that households with higher socioeconomic status generally have higher academic performance than households with lower socioeconomic status. But even that is not a satisfying explanation for why, okay? The why part is very complex and difficult to answer. Anything from, you know, systemic disadvantages to all sorts of other stuff going on. The why part is difficult. Statistics can't answer the why, but it can point us in the direction for where we need to study. Observational studies can't tell us what cause and effect things. It can't tell us these why parts, okay? But it can point us in the right direction. So observational studies are still useful in that they reveal these associations, even if we can't make a cause and effect conclusion, okay? I said statistics can't tell us why. Sometimes they can, and sometimes we can use experiments, okay? Experiments, or controlled experiments, this is another way of gathering data, okay? And in the controlled experiment, again, I'm going to use the word ideally. Ideally, the researcher can control all aspects of variation. okay? Control all aspects of variation, we'll say, for the participants. The researcher will also assign treatments to the subjects. Okay, and so let me just kind of describe the ideal. Here's an ideal scenario. Okay, we have group 1 and we have group 2. Okay, group 1, this will get the experimental drug. Group 2, they get the placebo. Okay, and then everything, and I mean everything else about group 1 and group 2 is identical. So let's say this is an experimental drug to see if it to fight lung cancer or something like that. See if it helps people with lung cancer improve their condition. And so in the ideal scenario, everything about these two groups are identical. They both have the same diet. They both get the same amount of sleep. You know, everybody in group 1, everybody in group 2 gets the same amount of sleep. They're all breathing the same air, same quality air. They all get the same amount of exercise. They all have the same levels of happiness and satisfaction and stress in life. You know, and the only difference between group 1 and group 2 is that group 1 got the experimental drug and group 2 did not. Okay? And then so at the end of our study, let's say at the end of the study, you know, group 1 has a higher rate of improvement than group 2. Okay? Well, because we have controlled everything about these people and we have randomly assigned who gets the experimental drug and who gets the placebo, if we find that group 1 has improved and group 2 did not, we can then attribute that difference to the fact that group 1 got the drug and group 2 did not. Okay? Because everything else about these groups were controlled to be the same. Okay? So the difference attributed to the different treatments. There's like a party out there and we're missing out. So the difference can be attributed to the different treatments because everything else was held the same, right? The problem is that so we can make cause and effect conclusions. But the problem is that experiments might not be ethically or practically possible, right? And trying to control all aspects of variation is not going to be actually possible. So you need to allow for some give there. But certain experiments just aren't ethically possible. You know, let's say we wanted to know the effects of long-term cocaine use on the brain. Okay, for an experiment to be done, we have to say, all right, thank you 100 volunteers for signing up for this experiment. We have randomly assigned you to two groups. Group A, you 50, do not touch cocaine, do not go anywhere near cocaine for the next 20 years. Group B, guess what? Starting tomorrow, we're going to have you use cocaine every day for the next 20 years, and we will see what effects it has on your brain. That's just not going to work, right? So those types of experiments aren't possible. Maybe we can use them on test animals or something like that, or we just have to do observational studies, but then you cannot make cause and effect conclusions. All right, we'll wrap up here, and then we'll see you guys on Friday.